So yesterday we did a big review of Minesweeper and we talked about state and handling events and pushing functions around to handle when things are happening. Today what we're going to show you is libraries that help you deal with state and events and all those things. Right? So React itself comes with its base support for props and state. And there are lots of other libraries that you can add into React to help you manage state in different ways. The two that we normally talk about are MOBX and Redux. Redux as its own thing, we don't go into deeply because it's quite complex, and to teach it to you would probably just take a full week of working through how Redux works. That's a thing we normally leave for students as like an exercise on your own to teach yourself post-graduation, because it's very popular in the React world. But it's one of those things that just falls off the list of like, I'm already breaking your brain so hard that Redux, you just run screaming from the room and never come back if we put you into Redux. Because React is already a different way of thinking, after JavaScript is a different way of thinking, and Redux is a different way of thinking on top of this different way of thinking. So just know that Redux is a thing. You're going to hear people talk about Redux and Flux and some of these state management libraries. Just know that they're a thing. You can go and read about them on your own. I think perhaps Wes Boss talks about them a little bit in his videos. I don't remember if he's going over Redux. Just remember that's a thing. The one that we're going to talk about is called MOBX, M-O-B-X, MOBX. And I think it's a good compromise between React's default state, how it deals with state, and something as complex as Redux. So I've pushed this base React project to our shared GitHub. So if you're looking to follow along, all I've done is created a React app called MOBX and have run that. So if you feel like following along, great. If you just want to follow along from the commits, great. Either of those are fine. So I think what we'll do is we will build a very simple counter. My computer's going so slow, like painfully slow. It did not do this the first day that I had to use QuickTime to record, but now it is. So let's see. Let's make I'm going to put a counter component in our app. So let's make a new component called counter, and all it's going to do is just display a count. That's all we want this counter to do. So we're going to make this counter.js. Almost unusable. I also have tried changing my font to see if this font is any easier for y'all to see the difference between braces and parentheses. I don't know if it is. We'll find out. Okay. I'm just trying different fonts to see if it's any clearer. So let's just have this component display a count. And we'll go back to our app.js and we'll import this component. Wow. I'm not even typing and it's like still trying to figure out it's typing. What is taking up all of my processing? Holy smolies. Okay, code helper. Whatever code helper is. Visual Studio Code. And QuickTime trying to record. All right, I'm gonna have to get with Jason to figure this out. Okay, so here's our counter. Right, we just have a little counter on the page. And what we're gonna do is let's make this button. Let's make a button. Let's put a button on here. All right, let's put this div here, and let's put a button for increment. And let's put a button for decrement. Here's our counter. And let's put this, let's put the number itself inside of a p tag. So we get a little bit of interface. So here's our counter. We've got a 0, an increment, and a decrement. Let's do this with state and see what happens. So let's make a state object that has the current value in it. And then instead of hard coding the 0, we'll put this dot state dot value. Right. And nothing's changed so far. Right. Pretty straightforward. Let's add a function to increment. So if we're going to increment, let's set the state of the value to whatever this dot state dot value is plus 1. And decrement will be very similar. That will just subtract 1. So here's our state with increment and decrement. And we'll just add some functions. On click this dot increment, and this one is decrement. So a state and 2 functions, one that adds to the value and one that subtracts from the value. 1, 1, 1. Everybody kind of, this should feel kind of familiar-ish. Right, so here's the state, and we've got increment and decrement, and here's our counter. This is great. Let me commit this. I'm going to do it this way. Basic counter with increment, decrement. Check.
In your comments, you can put any type of slash or.
Mm-hmm.
Okay.
Yeah. If you don't use this interface, you can actually type whole paragraphs, and many developers do. So, for instance, if we look at the Linux source tree, they do a great job of what is the Linux source tree? Linux. Where's the Linux source tree? GitHub Linux. This is an example of long paragraphs and commits. Oh, it's under Linus's personal account. All right, if we look at their commits, look at that, 797,000 commits. Yeah. So if we look at some of their commits, let's find a good one. Here's a whole paragraph about what this commit did. All right, here's a whole paragraph. I'm trying to find, sometimes you get really good ones. Like there's just like a whole story in it. Right? whole paragraph. Here's a whole paragraph of what happened. So most developers try and give nice, long descriptions. The typical view is the very first message you type should be a short, like less than, say, 60 character, right? NetBridge, fix VLAN stats, use after free on destruction. Like that's the short description. And then you type in like a description, like you could be sending an email to somebody saying what work you did, right? This person reported the use after free of the global VLAN context on port, blah, 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 blah. When I did this, this happened. And when I did this, this happened. I've chosen to do it this way. And here's like the 2 versions of what I tried. Like that's a fairly good commit message. Like if you were working on a team, right? Because I can come back to this later and see what all was there. Like it works is not a great commit message. And I'll send at some point a couple blog posts about how to make good commit messages. For class, we don't do as great commit messages. So here's our state. All right, this works. Now, if I wanted to be able to have the state up here, right, this is kind of what we ran into in Minesweeper. If what we wanted was the state to actually be up here, and we wanted to pass the value down to the counter, and we're going to move the state up here. So we're going to move all these incrementers and decrementers up here, and we're going to pass the value down. So instead of this.state.value, this is this.props.value. Instead of this.increment, this is this.props.increment and decrement. And now we have to pass the functions down as well. And we have to pass decrement down as this.decrement. Right? This should feel a little bit more like how we did. This should still work. Increment and decrement. Now the state is up in the app, and we're passing information down to the counter. This is kind of like how we had the state up in the app, right, or our board, and we were passing information down to the cells. But now I can have multiple counters. And it doesn't matter which one I increment or decrement, right, because they're all incrementing and decrementing the same state, and we're still passing down that value. Did that transition make sense, or are we confused? It's okay to say I'm confused. If you're confused, raise your hand. Cool. So before we had the counter maintaining its own state, and the functions for changing state were in the counter. If we want the state to be up above in the parent, rather than the child, right? The parent is the app and the child is the counter. We want the parent to keep track of the state. Right? Here's the parent creating the state in the constructor and modifying the state in these functions, but it's going to pass the value down to the child counter. If so, it also then needs to pass down 2 functions, one to increment and one to decrement. And then in the counter, rather than call its own increment and decrement functions, it calls the ones that were passed from the parent. When this increment is clicked, we're not calling anything in the counter. We're calling this function all the way up here in the app. So this increment is actually calling the increment in the app. This decrement is calling the decrement in the app. This is calling the increment in the app. So when we change the state in the app, we're changing this state value. This component is being re-rendered. That's what's causing all of these counters to change, regardless of which one we increment and decrement. Right? But we had to do all this extra work. Right? We had to have a state here, and we had to have this.setState and change all these things and pass functions down and pass values down from the app to the counter, right? Did we not? Did we not commit this? Oh, we just added more. Oh, we moved up to the state. So let's commit this. Move state to the app. Now have to pass values and functions to the counter. Right? So this is great, but you can imagine, as I did a little bit with Minesweeper, that this can get kind of out of hand. Right? Imagine if we had more things in increment and decrement. What if we had 20 different actions that could happen to a counter? Right? We'd be passing functions down and calling them up, and it could get to be a little bit of a mess. Right? So state management in React is kind of unopinionated. Right? They give you some basics, and this is kind of how you work with it. If you end up having something more complex, you tend to add more libraries to your code to avoid having to write this, right? React kind of took away all that boilerplate that we had of plain JavaScript, but has added a new boilerplate to us. We live with that for a while until the feedback of this is too much code happens, and then we look for libraries to get rid of that boilerplate. The one we're going to look at is called MOBX. So MOBX is another library for managing state. It has lots of parts, right? It's got lots of documentation. We're going to go over some of the basics so you can kind of see how it works. And then we'll talk about sort of the difference between it and regular state management. So MOBX is a third-party library, kind of like React is a third-party. Question?
I guess I'm missing why we moved it in the first place.
We moved it to the parent because I wanted there to be multiple counters on the page, and I want them all to react the same way. I want all of the counters to show the same counter, and I want them all to be able to increment and decrement the counter.
So if you left it in the counter, then just multiple.
I would have had different counters. If I go back a commit and had 3 counters on the page, this would only increment its counter, this would only increment its counter, and this would only increment its own counter. So I want there to be one value, and I want them all to reflect that value, no matter which increment and decrement I do. It's a silly requirement. It's only created that way to demonstrate to you why we would need a library like this. It's similar to the same problem of having Minesweeper, and in the end, I'm going to go back and redo Minesweeper with MOBX to show you why. But I don't want to start with Minesweeper because there's a lot of complications in Minesweeper. I want to start with a simple example of why when you have state in the parent and you're passing that property down to the child, but it's the child that wants to make a change to the parent, well, we have to do this state flows down, events flow up loop that blows your brains, right? This is a smaller version of Minesweeper that demonstrates the same problem that Minesweeper blew your brains with, right? So this is not as much code to have to deal with, but it still demonstrates the same problem. Right? I want there to be one value that all of these counters get. And the counter has the clicks to increment and decrement that state. So now I want to deal with it in a different way. I don't want to have to pass these values around and pass these increment and decrement functions around. I want to find a simpler way of achieving the same thing. So we're going to add MOBX to our app. So we're going to add MOBX and MOBX React. These 2 packages we're going to add to our app. And this time I'm going to remember to restart Yarn. So like we
Sorry. We have to do this for every project?
Yep.
Add MOBX?
For any project where you want to add MOBX. So any project where you want to add package X, you have to add package X to the project. Right? App and create React app, by default add React and JavaScript, and it adds things to your project. Beyond that, anything that you want in addition to, you must add to your own project. Right? So you see it brought in more than just MOBX, and brought in some components that it needs. I'm going to restart my yarn start. Question?
So you don't have to install MOBX more broadly on your...
It is a library that my project is dependent on. Therefore, I install it as the dependency of my project. If it's a general tool that I'm going to use across my computer, then I would install it globally. And the installation instructions for each library will tell you what to do. This one told me to only install it locally into my project. And I'm not going to walk through all the documentation because it's enormous. I'm going to distill some of this down for you in terms of what you would need. But MOBX is a good one to go and try and read the documentation. Soon you will need to start to be able to read documentation beyond just like the JavaScript code, documentation, MDN, and things that I say in lecture. Because soon you won't have my lectures to rewatch all the time. And you'll have to be able to read some documentation and distill it on your own. And MOBX is not a bad one in terms of its documentation. And they give lots of links and examples and links to videos. Not all documentation is good, unfortunately.
I'm sorry. I do see where it says npm install MOBX.
Yep.
So did you
I used yarn instead. Yarn and npm are swappable. We're using yarn, so we have to use the yarn instructions. But they don't give us the yarn instructions.
Okay.
Yep. So we've chosen to use yarn, but MOBX is only giving the npm instructions. So I know how to translate npm install instructions into yarn add instructions. You will learn how to do that eventually yourself. Right. Since there are multiple tools, there are at least 8 different package manager tools for JavaScript that one could use. They're not going to give you all 8 instructions. If you're using PNMP, if you're using yarn, if you're using npm, if you're using all different 8 package managers, they're going to give you typically 1 or 2. Like, here's how to do it with npm. You yourself, the developer, say, oh, well, I'm using this other package manager instead of npm. I know that npm install mobx -- save is the same thing as doing yarn add mobx.
Cool.
But you all don't know that stuff yet. So I sprinkle past it.
That makes sense, though.
Yeah. So we added the MOBX library to our package. And now we need to talk about a couple of things. MOBX works on this idea of observables and observers. Observables and observers. Observables are the things, the data in our components, the data in our app that we want MOBX to watch for us. So we're telling MOBX this value I want you to watch. And when this changes, I want you to, anywhere where that observable is being observed, I want you to react. Right? So if we tell MOBX that a particular value is observed, then MOBX is going to start watching that value, and every time that value changes, it will know that anybody who's observing that change should get repainted. Right? Observable is the thing that we're watching, and an observer is the thing that's being watched. Sorry, the thing that's watching it. Right? So in our system, it is this value that we are observing. So we're going to change this away from being this.state. We're just going to make it a property of the object. And instead of this.setState, we're just going to increment the value. And instead of this.setState, we're going to decrement the value. And instead of this.state.value, it's just this object's value. And we are not using the state. Right? we just have the value. But we have to tell MOBX that we are going to observe, that we're going to observe this value. Right? So we need to make this, computer,
Yeah.
really? Yes?
Do we not need to import it?
We're going to do that in a second.
Oh, okay.
Yeah, we haven't started using MOBX. We're just changing our component to just use a plain variable. And now we're going to make this observable. So to go to my reference for a second. Because I made myself a cheat sheet this morning. I want to reference my cheat sheet. Cool. So we are going to import two things. We're going to import these two things. We're going to import, these are all the things eventually that we're going to import. I'm going to import all of them. We don't need all of them here. But these are the things that we're going to import. Observable and observer, decorate and computed. And we're going to go through what each of these are. And you'll see that some of them come from MOBX, and observer comes from MOBX React. So MOBX is the general library for our data management, and MOBX React is what hooks that up to React. So we're going to import all of these into our app. I'll dump this in Slack so it's a little bit easier in case you're typing along. Right. So we're going to import all of these. Decorate, computed, observable, and observable. So now, we're going to decorate, and this is just kind of like how you might think. We're going to take this app component, and we're going to add capabilities to it via decoration, right? Like you buy your Christmas tree, and it's plain, and you put decorations on it, and it's fancy. Same idea here. We have our app, and it's plain. Doesn't know anything about MOBX. And we're going to decorate the app, and we're going to tell it that the value is observable. Right? Tell the app component that it has MOBX superpowers and that the value should be observable. Right? This decorate comes from MOBX, and so does observable. So this decorate is this function that we got from MOBX, and we're calling it and saying that our app component is going to say its value is observable. If we have more things in here, we're going to come back and add some more things. But for now, we're just saying, MOBX, please, in my app, make the value variable observable. So let's see what happens as we do this. Right? Nothing. Boo. In the counter, we have to tell the counter that it's an observer. So let's come back to here and grab just the observer. And we'll wrap the counter in an observer. So now the counter knows that it's sitting around waiting for when MOBX is going to change something. It's waiting for anything in the MOBX universe to change. And the thing that we are waiting for is for the counter to change. And it's not changing.
Do we still pass it as a prop?
Yes, we're passing it as a prop. And this is incrementing. And this is not changing because it's an observer. this is an observer. Let's see if this is actually calling. Because I expected that to work. So let's debug it and see what's going on. Let's see if we, in the console here, that's happening. And we are making the value observable. But this isn't working. Let's try it this way. So this is where I want it to go. I'm not sure why this is not working. We're decorating the app, and we're telling it that that value is observable. Let's make app an observer as well. Maybe that has to be. There we go. The app has to be an observer too. It has to observe its own change. There we go. Right. So now we're telling it that this is observable. Right. But we still have this increment and decrement because this app owns the value. Right. And it's still having to pass it down to the counter, and the counter still has to call back to the app because that's where the increment is. Right? It'd be nice if we could have this data on its own. So let me add this. Let me add MOBX now managing the value of our counter. Right? But it'd be nice if we didn't have to do that, right? It's kind of the idea. All we've kind of done is replace state with MOBX, right? Not perfect, but cool. Let's add another JavaScript file called a store, right? This is going to store some data. Maybe stores, let's use a different word first. Let's call it a data store, right? The data store is where our data is going to be stored. It's not going to be a React component, it's just going to be a plain old class. And we're going to export the data store. Actually, let's wait a second. So the data store is going to be where all of our data is kept. All our applications data will be here in this class. So the purpose of this class is to keep all of our data. Right now, the only data that we have is this one value. But if this was Minesweeper, it would be the game state, right? If this was a to-do list, it would be the list of to-dos, etc. So let's move this, right? Our constructor, our increment, and our decrement into the data store. Yes. So the data store is going to kind of be the one truth of where our data is stored. Right. So data store is a pretty simple object now. It just has a value, and it has an increment function that no longer takes an event. And all it's going to do is increment and decrement its value. Right. And we're going to decorate it. We're going to decorate now the data store and say that its value is observable. And then let's put these imports in here. All right, so here's our data store. It's a plain old class. right? It's not going to extend a component. It's not a React component. It's just a class for storing data. It's going to store its value. It's going to be able to increment and decrement. And it's going to observe, make its value observable. So now what we're hoping to be able to do is get rid of this. All right, we just want 3 counters here.
When it extends a component, does that mean like something displays or something?
This extends component. You can think of, when you see the word extends, think of is a. App is a component. Or think of is a kind of. That's what you should, the word extends, when you're translating it from programming language to human language, should translate to is a or is a kind of. So an app is a kind of component, right? And counter is a kind of component. They're also known as child classes or derived classes. And we're saying that our app is a kind of a React component and our counter is a kind of React component, but our data store is just a plain old class. It's not a kind of anything. It's just itself. It has no superpowers that it got from components because we're not going to put it on the display, right? We're only using the data store to store some information. Its only purpose is to keep this value around, right? Our components are going to end up using it. And we're going to see that in a second. Right, so I'm not passing this value around anymore. And what we've said is we're not going to pass this incrementer around. So what are we going to do? Well, let's make a data store as a new data store. This is going back all the way back to like week 2 of JavaScript, maybe week 3 when we talked about classes. We're going to make a data store here locally, but what we're going to export, let's call it our one data store. How about our one and only data store? So we made one data store, and that's what we're going to export. So this data store.js does not export the class. It exports the one data store we created, and we said that the data store itself is observable. Its value is observable. So in my counter, I can import something from data store. What I'm going to import is a lowercase data store, indicating that this is a single variable, not a class. Right? The data store that I'm importing from this data store is not the class data store. I'm importing the one and only data store. This is a Taco Tuesday. I can call this whatever I want. Question?
So data store is considered a child counter?
No.
No.
Mm-mm. Data store is its own thing.
Oh yeah.
Data store is just a class.
Right.
I could have called this Taco Tuesday. Does not matter. The class here, because I'm not even exporting the class.
Yeah.
Notice that in the counter, what do we export? We export the class itself so that we can use the counter here.
Yeah.
But in the case of the data store, I want there to be one data store in my entire application. I don't want multiple separate data stores. I want there to be just one of them. No matter where I import this data store, I mean to say the same data store, the same keeper of data. So I'm not going to export the class. I'm going to export the one and only data store that I created. So this actually makes one data store and says, anytime you require me, I'm going to give you back that same data store. That's important. Because here, right, let's call this the imported data store. Because we're going to get the value of this data store. And when the app reloads, and did I get an error? Nope. Oops. Too big. Cannot read value of undefined. Our data store. Oh, it's not this dot imported data store, it's just imported data store. Right, because that's the variable. Right, there's our value. And we're not going to call this dot props dot increment. We're just going to call imported data store increment, because that's the variable that has the increment function on it. And everything still works.
Can you explain that again, why you didn't say this?
So this counter does not own that variable. I didn't do this dot foo equals blah. This is like your JSON import. Remember when you imported your JSON? Did you do this dot octocats?
Yeah.
No, you did not. You just said octocats, right? In the app, when I import the counter, I don't say this dot counter. I just say counter. I'm telling the counter, you now have a variable called imported data store. It's independent of your own class, so there's no this dot. Right? So if I can now have this data store that knows about its value, and that value is observable, anywhere that I make a component that is an observer and imports that data store, I can ask for its value. And everywhere that that increment or decrement happens, right, I get the same value. What if I wanted to, on my app, also import right? And what if up here, I just wanted a p tag right? Now, anywhere where I import this data store and display it, as long as that component is observable, right? If I put a button here and I say on click, call imported data store increment, oh, sorry, decrement. Right. Right. That works. So I'm not passing state around. I'm not passing functions down so they can be called back up. I'm making one source of truth for my application. And I'm saying, hey, MOBX, please watch this one variable. And if anybody is an observer and they're using that variable, please tell them when that variable changes. I don't have to do all the this dot set state stuff. This dot set state value is value plus 1, right? I just say, hey, make the value more. And it just does it. Question, Kenny?
Is the R one and only data store the same as import?
No. So this is the value that we're exporting, right? So what we're saying here is I don't want to export this class. I want there to be one of these. I want there to only ever be one instance of the data store. If I exported the class, every person who imported it would have to make a new one. Just like here, when I import this counter, remember how we said that this counter is a separate instance than this counter, which is a separate instance than this counter, and each of those have their own state? Now we kind of want the opposite of that. We only want there to be one. So in our data store.js, once we create our class, we instantiate one of them. Right? We give birth to just one data store. We stuff that in a variable called our one and only data store, Taco Tuesday. I got you. I'll come back to you. And we oh, we're stretching? Okay. And we export it.
I have a question.
Okay, good.
Sorry.
All right, so we make one and we export it. So in our application, there's only ever one instance of the data store, and that's the one that holds our value. So when we import it places, again here Taco Tuesday, right? I could just call this X. Right? And this will still work.
So we're importing the whole data store.
We're importing this one variable. We're importing whatever we export. What are we exporting? Well, the one copy.
We're importing that file and everything in that file?
No. We are only importing that which is exported. Let's give an example. Let's make an example, because I think this is an important thing. Let's make a new component called how do exports work? And this file is going to export default 42. That's all it's going to do. Let's make a class in here, WTF. All right. I'm just going to have a constructor that's going to this dot value equals 99. But what's going to export is a 42. In my app, if I import how do exports work from how do exports work, and if inside of here I console.log how do exports work, what do we think is going to show up in the log? Just a 42. Because the only thing that gets exported is that number. So when you import something, you can only import that which is exported. So this WTF class is unusable by anybody because we're not exporting it. Now what if I exported the class WT? Now I'm going to export an object. Oops. I'm exporting an object. Now, if I console log what this is, look, I get a class, and a number. So you have a class, my WTF class, and my number. That's because I exported this class and this number. So if I only want the number, I do this kind of style. Oh, that looks familiar, doesn't it? It's like this. Now, what I have here is just the number. It says I'm not exporting. Number is not exported from how does this work? Let me research why that's not working, because that should be how that works, right? But this is just a little experiment, right? So the only thing we're exporting, I'll look up why that's not working. The only thing that we're importing is that which is exported. So it doesn't matter what's in this data store class, other than the fact that we're exporting this.
So you're importing new data store.
I'm importing the one new data store that I made.
Right. Okay.
So I'm asking this class make one and only one. And there's a name for this in computers.
Doesn't matter what you call it.
Does not matter what I call it here. Does not matter what I call the data store, as long as I'm using the names consistently, right? Some developers would just do this. And get rid of the variable. But I know you all like to see the little variables, and giving them names helps. So in programming, let me make sure I've fixed all this. In programming, we call this a singleton. And a singleton is a value that is created one and only one time. It's a singleton. There's only ever one data store in our whole app, right? Because we created it here, and it's the only way we get access to it is exporting it. John, did you have a question before I come back to Toby's question?
I'm gonna have trouble explaining this one.
Mhm.
But if you, let's say you've got a data store that's being used by multiple files,
Mm-hmm.
and let's say for some reason you wanted to alter the original data store that's referencing all of the other stuff,
Mm-hmm.
could you import the original data store into one of those files that's accessing it, do whatever you want over there, and then have it affect all the others, but not the others affect that one?
No, because we just have one data store. So you notice here in the app, I'm also printing the value of the data store, and I'm also having a button that affects it. Right?
Okay.
Right. So what if we had our own function here? Let's call this one increment twice. So increment twice is a function that takes an event, and it's going to call the imported data store. Imported data store. Let's call it decrement twice. Let's call it decrement, and let's call decrement. And instead of this calling that, let's call this decrement twice.
I'm saying if you change the import to data store.
This here, this does not matter what I call it here. This is Taco Tuesday.
So it's Taco Tuesday no matter what you call it, even if you call it Thursday.
Yes, because I don't even have to call React. I can call it Gavin's Funky React.
Okay, so there's no way to reference back to screw that up.
Yeah, I can only access the variable that was exported, and I get to call it whatever I want when I import it. So locally, DataStore.js can call it whatever it wants. When I import it, I can call it whatever I want. Almost 100% of the time, the thing that you export is the name of the file that you're in, which is the name that you call it when you import it, because it gets crazy when you start calling these things different things in different places. Right? If I were doing this when I wasn't making a point, I would call this data store. And I'm using a lowercase first variable name because we said that the ones that start with a capital we tend to refer to as classes, and the ones that are lowercase we tend to refer to as variables. So I'm conveying that this is really a variable. Did you see how we imported Axios, little Axios, not capital A Axios? And we did little a Axios dot, kind of like we're doing datastore.decrement and datastore.value, because Axios is exporting an object, not a class. That's why it's little a Axios. So now, hopefully, if we do this, and we increment this, and we decrement this twice, we get a 5. Right? Let's have the counter keep a history. What's up, Toby?
So you would only, I'm having trouble talking about this, but data store, you would only make that if you have one component that does the exact same thing every time.
So, actually, you know what? Let's skip this. Let me, because we've got about half an hour, because I want to end a little early today. I'm going to stop here, and I'm gonna redo our Minesweeper with MOBX so you can see the difference. I think that will help. So let's commit this, and then let's switch over to our Minesweeper implementation. What did we do here?
Yeah.
This is a data store. So here, we implement and use a data store. So let's save this, and let's push this. Let's close all of this, and let's stop this, and then let's go back to day, actually, let's copy yesterday's, actually, let's go back to yesterday's Minesweeper, and then let's copy yesterday's day 1 Minesweeper here. And let's rename Minesweeper to MOBX Minesweeper. So I'm just making a copy of it so it's separate. Right. But if you wanted to add MOBX to your Minesweeper, you would just do it where your Minesweeper is. And then let's yarn install. And then when that's done, we'll add MOBX. Right. So in Minesweeper, how would you describe the state that we were keeping? It's the state of the, yeah, more so the game or game board, right? Because it has more things than just the board. It has the board and the number of mines and the state. So we think of that as the game. That's what we're going to call our data store when we create Minesweeper here in a second. Question or stretch?
Stretch.
Okay,
Sorry.
no worries. Just want to make sure. So after this is done, we're just installing the packages so we can have it. We'll add MOBX and MOBX React, and we'll see how changing Minesweeper works. I hate that this takes so long.
They need a dinosaur game. Like,
Yeah, for something. And it's the streaming of the Chrome and the recording. It just really slows it down because it's not this slow when I'm not doing this. Okay. So let's add.
App cache?
There is.
That you could do, maybe?
There's a way you can cache the packages, but the part that's slow is all the other bits.
Well, I'm saying, maybe the problem is it's caching something and then
No.
it's screwing up because it didn't happen the first day, right?
Yeah. I don't think so. I don't think so. Either that or I just didn't notice as much the first day. Okay, so let's just have our Minesweeper with MOBX added. Oh my god. Okay. And then let's yarn start. And let's just make sure that our Minesweeper is still working from where we were before. Cool. Okay. Here's our Minesweeper. And then let's make Minesweeper full screen. And then we'll put this on the side. Here we go. Okay, hopefully. Let's commit this as non-MOBX version of Minesweeper. So we have that as a commit. Okay. So here's our app. Right. And we've got all this state up in here. Right. We've got our state, and then we've got our functions for making a new game, and functions for flagging cells, and functions for checking cells, etc. Those are the parts that modify the state. What we're going to do is we're going to make a new component called our game. And it's actually not going to be a component, it's just going to be a plain old class. And this class is going to have a constructor. What's going to go in that constructor is this stuff. Stop it, phone. It's just this stuff. It's just this stuff. So let's put this inside of here. And let's put this inside of here. now what we can get rid of is, let's call this from the API. So we can get to now kind of rename some of these things. API, and this is the game, and this closes the constructor. And that closes. Why is this red? This closes the game. This closes the API. Why is this red? What's it saying? What don't you like? Oh, maybe nothing. Okay. So we're making a new class just to maintain this game. And now I'm going to be able to rename some of these things, right? I want my game and my game just to store my playing, the difficulty, and what comes back from the API. So let's add in to this the bits we need from MOBX. It was these bits. Let's add in MOBX parts. Let's decorate our game and say that our game is observable. Then, let's make our one and only game be a new game and export just as our one and only game. I'm just going to export that one game. Question?
Is there a particular reason you do the let equals?
I'm just making, I'm making a variable. Let people equals, right? Just making a plain old variable.
Can't
Right.
you just put like new games there?
I can, but where would it go? If I just did this,
Optimal for the export.
how would I export it? Right. I could just say export default our one and only game. Like this. I can get rid of this.
So is there a particular reason you define it?
Because it's easier for your brains to understand it when I give it a name. If I do that syntax, half of you would be more lost than half of you are already lost, right? Like, I look out and I see glassy eyes everywhere. And people, who's totally confused?
Somewhat confused.
Who's half confused? Yeah. So like, the more that I do this, the more when I ask who's totally confused, who's half confused, who's got it, like those numbers go down. So I tend to add extra variables just so that I can name things, just so that when you go back and watch the video, you're like, oh, that game is our one and only game. If I were writing this in production code, I would not do this, right? If this was production code, I would feel okay just saying default the new game, right? In production code, I would do this instead. Right? There's no reason for that variable other than it helps make something that's already kind of confusing a little bit less confusing. Cool. So this is our game. Let's come back to our app and let's add MOBX to our app. We can get rid of our constructor. We don't need it anymore. Let's also import game from game. This is painful. Well, this is how we make a new game, but this really belongs in our game. So let's add this function to our game. The difficulty is now just this dot game difficulty. We don't have to this dot set state anymore. We can just say this game playing is true, and this game dot API is the response data. right? No set state. Let's just make this playing. You know what? I don't even need this game. Let's do it this way. This will be even easier. Less things to type. No, I know why I did it. Scratch that. Let's do it this way. This game playing is true, and this game API is response data. This game playing becomes true, and this game API becomes what we get back from the API. So here's a new game. What else do we have in here? Flag cell and check cell. Let's move both of those into our game. So here's check cell and flag cell. So this is now this game playing. This game API ID. This game API ID. This dot game dot API is the response data. And then the same thing down here. This dot game playing. This dot game API ID. This game API ID. And finally, this game API is the response data.
Where's the API?
This game API. And then let's put the Axios stuff in here because now we're using it. It needs it. And it's not needed in here anymore. So now this becomes if the game is playing, that's a little bit weird, right? Maybe we'll call this our game. If our game is playing, and if our game API state is 1, our game API state is lost. If our game API.id I'm waiting to type one. I literally typed one. I was sitting there waiting for one. Just my typing speed and my computer's ability to keep up are not working together today. Our game, what did this even say? Yeah, fine. If our game is playing, then this, our game API mines. Our game API state. So this choose difficulty also needs to go in here. This just becomes this dot game dot difficulty is the event target value. So now this is no longer the state game board. This is game, our game API board. We don't need to pass these functions anymore. This becomes our game API board length. This becomes our game difficulty. This becomes our game, choose difficulty. This becomes our game, new game. This becomes our game, game, API. Oh, nope, this is just our board size. Did we leave this in here, board size? We did. And there's everything. So we refactored everything into one game, and you'll notice now all of these functions are in here, not in our app. So our app now is only responsible for dealing with its own thing. All the game information is in our game class. The last thing we need to do is import our game from game here, and then call our game check cell and our game flag cell. And hopefully we don't have too many errors in the refactoring. Because if there are, we'll have to delay it until 2. Let's see. Well, we don't have any errors, but our game isn't updating, right? When we click this, are we getting a new game happening? Let's see. There is. Oh, I know what we probably didn't do. We didn't make the cell an observer. And we didn't make the class an observer, like so. And we need to put these things in our cell. And we need to put these things, oh, they are, in our app. So we need to make all of these components also observers so they can see the change. There we go. Right. And now that works. So what we avoided doing is having to pass down these functions, and all of our game information is now stored in one class. If we, for some reason, wanted the cell to know how many mines there were, right? This would be silly, but we could put in here game. That's our game.game API mines. We wouldn't do this, but just to show you now, typo. That the cell, any component now has access to all of the data that we have in the game. Right? How silly is this, right? Like, right? As I'm flagging this, right? Notice I didn't have to pass the number of mines to the cell class. It's getting it because the game has all that information. And since it is observable, and our cell is an observer, when we import that singleton game, any changes to it arrive. So that's what's causing this mines to change, right? So this style of having one data store in your app where all your information is kept, making those elements in the store observable, then importing a singleton of that into your other components, still uses all the component nature of React, but we're not using React's own state management. We may still use it from time to time for things like input boxes. Remember when we did input boxes and we had to have state because we couldn't change the input box, right? We still may use it from time to time for those kinds of things, but the major part of our data, we may choose to use something like MOBX and store all of it here. Then we just import the singleton everywhere, and anytime this data changes, anybody who's importing that data and then using it, where are we using it? Right? Anybody who's using it will be notified of changes and repaint. So it has some of the same capabilities as React's own state management, but when you get lots of data and you're sending that data to a lot of places, and a lot of those components are sending you changes, right? You're clicking on things and changing. It avoids having to pass functions down and pass functions up and pass state to a child and from a child to a child and from a child to a child. Right? You just have that one store somewhere and you just import it wherever you need it. The other thing I would probably do here is I probably wouldn't put this inside of this game. I would probably change this to be this playing, this difficulty, and this API. Rather than have them be in an object, I would just have them be variables. And then I would, in here, instead of making game observable, I would make difficulty observable, and I would make playing observable, and I would make API observable. Right, I would just make these individual. Then this would just be this difficulty, this playing, this API. I would get rid of that double word game. The reason why I did it that way the first time was I didn't have to show you making three observables. And this makes it a little bit cleaner. This API ID, this API, this playing, this game API just becomes API. Right, so your store can observe multiple things. Right, so all of these are now observables. And now in our cell, this is fine. In our app, we can get rid of all the places where we did our game.game dot something. And that just becomes our game dot something. Right. We can observe more than one thing in our game. Right. So now our game has a playing difficulty and API, and our app just has our game.playing, our game.API state, our game.API ID. That's a little cleaner. This refactoring is a little better for the game, right? I didn't tuck all this into an object. I now had this game have three different observables, playing, difficulty, and API.
If you were to build Minesweeper, would you have just started out this way? I guess I'm wondering, like, at what point would we?
No, because I think Minesweeper is a good example of how to use React State Management.
Yeah.
We've debated from a curriculum perspective not teaching you that first, but teaching you MOBX first. Just showing you this is how you do it. And like, because we're going to build up more complex user interfaces that have more need for state and more need for passing things down and up. When you build your capstones, there's going to be lots of data flowing all over the place, more so than just clicking cells and having cells, right? You can have lists of things that are sorting and changing and clicking and deleting and editing, and data is going to be flowing left, right, and sideways. Doing that without some state management helper, you can totally do it, just a lot of extra work. So following this philosophy, we want to show you like how to do it the normal way, like the base way. So why we show you git add, git commit, before we show you clicking on this thing and just, type the thing and press the button, right? If we teach you type the thing and press the button, then you're really good at typing the thing and pressing the button. But then you arrive somewhere where there's no VS Code, and you're like, I don't know how to Git, right? Like, we didn't teach you Git, we taught you how to press these buttons. And we're trying to teach you something about Git, right? Same reason why we teach you React, not Angular. We taught Angular, and people were really good at pressing the Angular button. But then they had to go write JavaScript, and they're like, I don't know how to write JavaScript, I know how to write Angular. When we teach you React, we're teaching you JavaScript. It's still map, filter, classes, functions, events. Everything is still there. Nothing is hidden from you. The debate is for something like MOBX, do we teach you MOBX just hides away all the complexity of passing event handlers down and up, and the whole React data flows down, events flow up lifecycle? You get further, but maybe we're hiding some details away. So,
I would say, don't teach MOBX. If your
Yeah,
company
I'd say
says
teach
don't
state
teach.
first.
Yeah.
Yeah, if your company doesn't use MOBX, then you're like,
yeah.
oh my God.
Yeah, what do I do? Yeah, so it's one of those, like, do we teach you the easy way first and then show you the details? Or do we force you to, like, go through the pain of learning the details and then show you the nice way? Like, when we used to teach Rails as a full 9-week course, right? I didn't show students Rails until week 7 of 9 weeks. We essentially built the entire Rails framework, right, all the way up, and then like, hey, look, if you just install this one library called Rails, all these hundreds of lines of code that I made you learn how to do, you don't have to do anymore. But boy, you know what that library is doing, right? You can kind of feel a little bit, maybe just a little bit of what MOBX is doing for you, right? You probably don't feel it internally because we only did this for like 1 or 2 days, and now we're showing you a different way. But hopefully you can see like some of the things you don't have to do if you apply something like MOBX, right? If you go learn Redux, same kind of thing, right? We want to show you like all the gears behind the clock before we teach you like, oh, you just read the time from the face of the clock, right? You're learning how all those gears work to move the second hand and the minute hand. Maybe you'll never do it that way again. I don't know, right? You go do some front-end work, and they use a different state management library, not core React, or not MOBX, or not Redux. There's a new one that's come out, right? You know how those internals work, at least a little bit. You've had a taste, an appreciation for it. So when you go pick up that new thing, you see how it is, right? This is why I say, like, you don't feel like you have to understand everything we're throwing at you. We're trying to give you a base understanding of the low-level details of how each of these things work, and then a taste of, like, you don't have to do it that way all the time. There are better ways, right? So that when you arrive somewhere, right, and you have that first job, and your mentor says, oh, yeah, oh, we don't do React state management without a library. You silly? Oh, but we don't also use MOBX, and we don't use Redux. We use this thing that came from Netflix, and we use blah, blah, blah library. Cool, let me go learn how that library works. And then off you go, right? But if you arrive somewhere and it's not working, or you just want to use plain state in React, you know how to do that, right? You remember some part of it, or you remember which lecture to come back and rewatch, or you know which homework to go back and peek at, or which practice to go back and do. That's the idea, right? So I tell you, for larger apps that I've written, I wrote an app that there was an improv show we did that was like a game show version, kind of like Whose Line Is It Anyway, where the points don't matter, but everybody gets points for things. But we followed the points. So there were players and games, and points were assigned, and we keep track of them, and you could eliminate players. I may show it as a demo, probably not on video though. But crazy amount of state. Boy, did I use MOBX, because I did not want to have to dealing with state. So I was just like, I'm just going to throw MOBX in this project and use it, right? Different teams are going to do different things. So I don't necessarily expect you to like, I think I can throw MOBX in a project and just use it, right? But you'll know kind of the things that we talked about and the reference. Let me show you what your homework's going to be. It's not MOBX. It's not even React. Yeah. I want you to write your own state management library. Invent your own. No. We're going back to JavaScript. Let me see if I can find it. So I've made a homework assignment that's a lot like function junction, but it works just with iteration, map, for each, all of those as a practice on rebuilding our JavaScript function writing capabilities and dealing with all of the map and for each things. So it's going to work just like function junction. There's a repository you're going to fork, then you're going to clone it, yarn install, yarn test, the same setup that function junction had, and the same style. It's going to give you if it loads, it's going to give you a test file and ask you to write some functions inside of it. So inside of this function test, it's going to ask you, here's the very first test you're going to write. Define a function yelling that takes an array of strings as argument and returns a new array with all the words forced to uppercase. And it kind of shows you, like, example, this is what you're going to write right here. You're going to write const yelling takes an array and does something here. Right? So it's going to take in an array of strings, and whatever those strings are, you're going to transform them into the same thing, but all of the words forced to uppercase. And then, hey, here's another one. Define a function called double trouble that does a thing. Define a function this, right? Just like function junction was. But each of these you're going to solve using one of the enumerators that come from the array functions. So almost all of these can be solved if you go to the dev docs for JavaScript array, and you look at the section that talks about iteration. So here's methods, and here's accessor methods, and here's iteration methods. This part right here, iteration methods, you can solve all of these by using some of these. And you may have to figure out which one to use for which problem. If you keep going all the way down, there's some of these that have a yourself in them. Map yourself, filter yourself, every yourself. Consider these adventure mode. Try them, but consider them adventure mode. For instance, for filter yourself, you're not allowed to use any of the array enumerables to implement it. So no using for each, map, filter, reduce, etc. You got to implement it yourself. Cool? So I'm going to assign this, and then I'm going to run